All right, we've talked about lines, right? We've talked about points and all that kind of stuff. We're going to introduce something a little bit different, but very similar to what we just did. Put a dot here and a dot here. Now, what do you think that is? You think that's a line? It's a what? It's a segment. That's right. It's a line segment. Okay, good. So it's a line segment. It's not a whole line. How do you know it's not a whole line? That's right, because the dots stop right here, and it doesn't have what, Michaela, would you say? It doesn't have arrows, right? It doesn't have arrows, which means it doesn't keep on going. It actually has a place where it starts and stops, or you can think it stops on both ends. There's really no starting place or ending place. It just either it stops here and it stops here, okay? So we can actually measure that then, couldn't we? Could we measure a line? No, because the line keeps on going forever. You couldn't measure that. But you could measure something like this, because it has a place where it starts and it has a place where it stops. And we actually give a name to these points right here on the end. So they're points on the end. What do you think we call them? If they're, come on, follow my reasoning. They are. I'm trying to give you huge hints here. Okay, they're points on the end, so we call them end points. Good. Okay, good. I'm trying to make it easy for you to follow along. So those are end points. Even though some people say, well, that's a start point. Well, who says we always start right there? Could have started right here, couldn't we? So we don't call them start points. We call them end points. Because it's the end of the line segment, right? That's the end of this line segment, and that's the other end of the line segment. All right, so those are called line segments. If I said that was capital A and B right here, this is how we name or how we label a line segment. Remember how we labeled a line? We put the two letters. Did it matter what order we put the two letters in? Nope, didn't make any difference. And what did we put on top? Put a line with the two arrows on the end, right? Well, on a line segment, we kind of do the same thing. We call it line segment AB, but we don't put a line with arrows. We just put the line, and that's it, just like that. We don't put any dots on that little thing. Okay, we just leave it like this. Or, just like a line, I could call it AB, or what else could I call it? BA. Line segment BA. I could call it either one of those. It doesn't make any difference. So the order that you put the line segment in does not make any difference whatsoever. We good with that? All right. Now, what did I say earlier about line segments? I said we could actually measure these things, couldn't we? Well, what do you normally use to measure something of a certain length like that? A ruler, right. Okay. Now, I don't have a ruler. I probably, if I would have thought about it, I would have maybe downloaded one or made my own or something like that so you could see it. But let's make our own little ruler right here. All right, so let's say this was 0. Let's just say it's in the English system it's in inches, okay? So let's just say this is 1 inch, okay? We kind of blew it up. I know that's a lot bigger than 1 inch, okay? But let's say we just blew it up a little bit so we could see it, and we said this is 0 and this is 1, right? It's right here and right here. You with me on that? What I want to do is break it up, and you've probably seen this before. Now, I don't know if I'm exactly in the middle, but just pretend I am. All right? So, right there. Where would that spot be? That would be a 1/2 inch. Okay? If it was right in the middle, that would be 1/2 inch. You following me? Usually that line, not usually, I think every single time, that line's always bigger than the other lines. Now, if you look at the ruler, like if the ruler, you know, the ruler might have gone something like this. You see that? So this is not quite as big as the end of the rulers, but it's usually your biggest little dash line. Now, what if you went half of that? A third? It'd be a fourth, right? Because we're doing what? We split a half in half. So what's half of half? Look, half of means multiply. What's half of a half? It's a fourth, right? So what would this be? 1/4. And you could do the same thing over here too, couldn't you? All right, I'm just not going to do on the other side, just for the sake of time. What if I split that one in half? And notice my little dashes are getting a little bit smaller as I move on, aren't they? They're supposed to be anyway. What would this be? 1/8. Okay, and let's do one more. What if I went half of that? Oops. Right. If I went right there, then this would be 1/16 and 1/16. All right? Make sense? So there's examples on page 14 and 15 if you have your book open. There are examples. What they're going to do is this. They're going to give you a line segment. All right, so they're going to give you a line segment like this, and they're going to say, what is the measurement, or what's the measure, or the length of, find the length of that line segment. So if that's C and D, look at the top of page 15. Look at that. See the top of page 15 where it says CD? And using the ruler. So what's it do? It goes to 1, and then it goes just one little more than that. So what would that be? Is that 1/16? Because we said the one that's smallest is the 16th. Now you got to break them up. It depends on the ruler. Some rulers go a lot more detailed than other rulers. Some rulers don't go to 1/16. Some rulers go even more specific than that. Go to what? 1/32, right? 1/32. Would you agree? Not every ruler does that. Some only go to a 1/4. Okay, some only do a 1/2. Some go to an 1/8. All right, it just depends. Look at this first ruler on A. Do you see on the top of page 15, example 2A? All right, I'm not going to draw it up here, but you can see it. It's at 1 and what? 1/4. That's right, because the one next to it, the bigger one, is a 1/2, and that's 1/2 of a 1/2. So it would be about 1 1/4. Make sense? Look at part B. That's still 1 1/4, isn't it? Even though the ruler is more detailed, it's still 1 1/4. What's the most detailed that goes down to? What's the most specific? It goes to 1/16, right? So it's a 1/2, then a 1/4, then an 1/8, then a 16th. So it's just like this one I drew right here. Okay? Pretty easy, right? All right, let's pause that for a second and talk about another little. All right, here's another line segment. What I'm going to do is I'm going to put a point right here on this end, put a point on this end, so I got 2 endpoints, and let's put a point about right here. So tell you what, instead of using A, B all the time, let's go X, Y, and Z. Tell me something. You already learned this. This is not a trick question. What are points X and Y to this line segment?
Endpoints.
They're endpoints. Good. Okay, they're endpoints. What about Z? Z is not an endpoint of XY, is it? All right. Now, if I said line segment XZ, then Z would be an endpoint of line segment XZ, right? But if I'm talking about line segment XY, Z is not an endpoint. Where do you think Z is in relationship to X and Y? Well, I'm not looking for a number. I probably didn't word this in my last class very well because they didn't really get this, but I'm just trying to think of a better way to word it. It's not like outside it. It's not inside it. We say it's what? Like if I had Joe right here and Elizabeth right here, and I said, Zach, I want you to stand in here. Where would you be in relationship to them? You would be what? Between them. Okay, you would be between them. Not necessarily halfway. Is this necessarily halfway? No. But it is what? What's the word? Between. Okay, so we say that Z is between. I know a lot of people say in between. We're not going to say in between. We're just going to say between. So Z is between this. If Z is between it, it doesn't mean it's exactly halfway. Now, it could be, couldn't it? I mean, I could have Zach stand exactly halfway between you two. All right, but that doesn't mean you're always going to be halfway. Okay, you could be anywhere. If they're on either side of you, you're always between them. Does that make sense? So if you have somebody on your left and somebody on your right, you have to be where? Between those two people. Got it? So, big deal. How does that have to do with anything? Well, it does. Watch. I'm going to talk about XZ. All right, that's line segment XZ. What if I added it to this little bit right here, ZY? What would I get if I added those two together? Not a number, because I have no idea what the lengths of these things are. But XZ and ZY add up to what? The whole line, which is what? The whole line segment, which is XY, right? Line segment XY. Do you see that? So the lengths of these two segments, if I add them together, it's going to equal the length of this. Actually, they get a little picky on this. There we go. I'm just going to get rid of that, get rid of this, get rid of this. They don't actually, when they add them up and say it's equal to something, they don't actually put the line segment thing over top of it. What they do is they don't put anything over top of it, and what that means is the length of. Instead of writing out the word, the length of line segment XZ plus the length of line segment ZY is equal to the length of line segment XY. Instead of doing that, they don't put anything over top of it. So when you see 2 points next to each other like that, and you don't see any line segment over top of them, what does it mean? It means the, what did I just say? The length of, right, the length of those line segments. And you're going to see that quite often, really, throughout the year. If you don't see a little line segment over top, what does that mean? It means the length of them are equal to each other. For instance, if that was 5 and that was 2, what's the length of line segment XZ? It's 5 plus the length of line segment ZY, which is what? 2, equals the length of line segment XY, which would be what now? Which would be 7, okay? We're going to do a lot of that kind of stuff. So that is the key right there. Now look at the Z's. Do you see that? Do you see how it's in this one and this one? That means Z is what? It's between what? X and Y. Do you see it? Alright, it's between those two things. So that's what it means when it talks about things being between. We're going to do this quite a bit. We're going to take line segments and add them up and set them equal to the whole thing. Alright, so for instance, what if I said this? What if I didn't know what this was? If I didn't know what it was, what do you think I'm going to call it? Just call it like A, letter A. Alright, it's an unknown. You're right. It is an unknown. We'll call it letter A. And let's say I knew the whole thing. I'm going to pick a different number. Let's say the whole thing was like 15. Actually, I lied. Let's make it look a little bit more normal. I don't know. Let's just use the same number. Might as well. Let's just say it's 7. Okay? Alright, you with me so far? So the whole thing is 7. So XY is 7. Notice I didn't put a line segment over it. What does that mean? It means the length of. So when it doesn't have the little line, it means the length of. Everybody got that? So the length of XY, line segment XY is 7. The length of XZ is what? 5. What do you think they're asking for? The length of ZY equals question mark, or I put a little small letter in there, or you could say A. It's the same thing, isn't it? Alright, I didn't even have to put the A there, I guess. But how would you do that? That wouldn't be that hard, would it? Yeah, you just go 7 minus 5, or you could do it like this. Watch. Now, if I was to do this, I would definitely just look at this and say, oh, 7 minus 5 is 2. Alright? But I just want you to see how this works. Watch. I could say this. 5 plus A. What does 5 plus A equal? 5 plus A equals what? The whole thing, which is what? 7. Do some algebra. Subtract 5 from both sides. That cancels. A is what? 2. Right? You could do it like that, couldn't you? Now, sometimes the numbers are a little trickier. Things are a little bit trickier. I just wanted to show you how we take a geometry concept, set it up into an algebra problem, and then solve for it. That's really the first time that you've seen that, but it's not going to be the last. We're going to see this probably in every single... Are we listening? Pay attention up here. Every single chapter that we do, we're going to take a geometry principle and we're going to turn it into an algebra problem. Not on every single problem, but somewhere along the line in every single chapter that we do, we're going to take a geometry principle like this, like these line segments. We're going to set it up into an algebra problem, and then we're going to work the thing out. Okay? Let's do another example. Okay, here's a line segment, and I've got X, Y, and Z on this. This is a little bit different, but kind of the same. Watch. If I put a 3A here, what length is 3A? It's XY, right? And if I put a 14 sitting right here, what length is that? It's YZ. Now, if I do this, if I put a little bar and a line that goes like this, this is 5A minus 4. Okay? So you know the whole thing is 5A minus 4. Now, how would you set this up? This is very similar to what we just finished doing, isn't it? So let's take the two, if y is in between, what do? We take the two segments, add them up, and it equals what? The whole thing. Hang on, don't leave just yet. Watch, let's do this real quick. 3a plus 14 equals 5a minus 4, and now you just solve for a. You can do the math, and then you just solve for a, and you get 9. So a is equal to 9. If you wanted to, what's xy equal to then? It's 27, isn't it? All right, and I can figure out what everything else. 27 and 14 would be the whole thing. That's basically what you're going to do. Okay?